So in this video, we'll be discussing about the modular exponentiation. And we know that if a string which is in its base b form, let's say the string is ak minus 1, ak minus 2, so on to a1 and a0, and it's in its base b form, and let's say we have to convert it into a decimal form, then that will be equal to this expression. So if we have to calculate the value of this expression, b raised power n mod m, and we have to calculate it efficiently, we can do it by using small numbers such as 2. So just like we had a base b here, which represented any general base. Similarly, here we'll have a base of 2. So this n here in this example, this n will be written in terms of the power of 2. So n will be equal to, this value, but instead of b we'll be having 2. So this will become a k 2 raised power k plus a k minus 1 times 2 raised power k minus 1, so on to a1 2 plus a0. Therefore, this expression, using this value of n, this expression, modular expression, b raised power n will be equal to b raised power this whole thing, So this will be equal to b to the power of a k times 2 raised power k plus a k minus 1 times 2 raised power k minus 1, so on to a1 times 2 plus a0, and then we have a mod of m. Now this can be simplified further by using this kind of corollary here. By using this corollary, this expression can be expressed as b with the power of ak times 2 raised power k times b ak minus 1 times 2 raised power k minus 1 times b raised power ak minus 2 times 2 raised power k minus 2, so on to b raised power a1 times 2 times b raised power a0, and then we have mod of m. Now we'll be using the corollary here in this example. So each term will have its mod m. So this will be equal to, using the corollary, using this corollary. So far we didn't use the corollary, now we are using it. So this will be equal to b raised to power ak times 2 with the power of k. Then this will be having a mod of m. This will be multiplied by the second term here, which is b with the power of ak minus 1 times 2 raised to power k minus 1 mod of m, so on to b raised to power a1 times 2 mod m times b raised to power a0 mod m. So this entire thing will have a mod m at the end. So when we will obtain this expression, this can help us in simplifying this value. So using it directly might be very hard to calculate, but when we break it further using the corollary and the general way of representing it in a base 2 form, the power n, we are representing it in a base 2 form, so this will become easy. So that was the general concept of the modular exponentiation, and in upcoming videos we will be taking an example where we apply these concepts.